Okay, let's dive into this. Deep learning. I mean, you hear this term thrown around all the time, right? It's the magic behind your phone's camera. It's the brain in a self-driving car. But what actually is it? And maybe more importantly, how in the world did we teach a machine something that feels so, well, so human? Something like intuition? In this explainer, we're going to break it all down. So before we can even get to the solution, deep learning, we really have to understand the problem it was designed to solve. And, it's a really fascinating one that had AI researchers scratching their heads for decades. They were stuck on this strange paradox. How could a computer master something as incredibly complex as chess, but then completely fail at a task that a toddler finds easy? And this very contradiction, well, it got a name: the AI paradox. It was a huge sign that something was fundamentally wrong with our early approach to building smart machines. And it totally set the stage for a revolution in thinking. Just look at this contrast. It's pretty wild. Early AI was an absolute genius when it came to formal rules. You give it a complicated math problem or the rules of chess, and yeah, it could beat pretty much any human, no problem. But ask it to do something intuitive, something we do without even thinking about it, like just recognizing a friend's face in a photo, and it was just completely lost. So what was going on here? What was the actual problem? Well, the answer is in what we now call the old way of doing things, an approach called traditional machine learning. Turns out its entire design had this massive blind spot. The core of this older method really boils down to this one concept called a feature. Now, a feature is just a single piece of information, like a specific instruction we give to the machine. So, for instance, if you wanted an AI to identify a car, you might tell it to look for features like has four wheels or has headlights. They are the specific clues the machine is explicitly told to go out and find. And right here, this is the crucial limitation. This is the bottleneck. The machine's entire ability to perform, its entire intelligence, depended on a human programmer sitting down and carefully hand-picking every single one of those features beforehand. The AI couldn't discover any new clues on its own. You can see the split right here, the exact division of labor. The human did all the hard, creative, conceptual work, figuring out exactly what the machine should look for. The machine's only job was to find those predefined features and then map them to an answer. But what happens when the task is too complicated for a simple checklist? I mean, how do you even begin to write down the rules for recognizing a face? That's where the whole system just fell apart. Okay, so this is where everything changes. This is where deep learning enters the picture, and it just completely flips the script. It introduced this incredibly powerful new way for machines to learn, not from a list of rules that a human wrote, but from raw experience, kind of like we do. The core idea is just brilliant. Instead of giving the computer a super detailed checklist, you just give it a ton of raw data, and you let it figure out the important concepts for itself. It builds an understanding of the world by creating a hierarchy, starting with really simple ideas and then combining them to form more and more complex ones. This process is just perfectly shown by how a model learns to see a face. It doesn't start out looking for an eye. No way. It starts with the most basic thing possible, raw pixels, just dots of light. From there, it learns to identify simple things like edges and contours. Then it learns to combine those edges to recognize simple shapes, like the shape of an eye or a mouth. And finally, it learns that a specific arrangement of those shapes represents the really complex concept of a face. It builds understanding layer by layer from the bottom up. So that whole idea of building knowledge in layers, well, that is precisely where the name deep learning comes from. The depth here isn't just a cool metaphor. It's literally describing the structure of the AI model itself. You see, this whole learning process, it doesn't just happen in a vacuum. It all takes place inside something called an artificial neural network. And just like the name suggests, it's a computer system that's inspired by that massive network of neurons in our own brains, designed to process information in stages. The early neural networks were what we'd now call shallow. They might have had only one hidden layer of processing between the input and the output. That's kind of like having only one step to solve a problem. It really limits you to seeing simple relationships. But a deep network has multiple hidden layers. Each layer takes what the layer before it figured out and finds an even more abstract, more complex pattern. This layered structure is what lets it build that hierarchy of concepts and grasp these incredibly complicated relationships in the data. And this quote just nails it. It connects everything perfectly. The graph that shows how these concepts get built on top of each other, from pixels to edges to shapes to a face, that graph is literally deep with many, many layers. And the tech that makes that happen? That's deep learning. So by shifting that huge burden of feature finding from the human programmer over to the machine itself, deep learning basically unlocked a whole new era for AI. All of a sudden, it started solving problems that for decades we thought were just impossible for a computer to handle. So, what's the big takeaway here? The deep learning revolution wasn't just about making networks bigger. It was a fundamental shift in philosophy. We went from telling a computer exactly how to solve a problem to just giving it a goal and letting it discover the how all by itself. And that's why it's so good at the messy, intuitive problems of the real world, from understanding what we say to identifying what's in a picture. It discovers the rules that we could never write down ourselves. Which leaves us with a pretty mind-bending final thought. We've actually built machines that can learn a kind of intuition. They can see and listen and perceive the world in ways that feel almost, well, organic. So the question isn't really if computers can learn anymore. The real question is, what are we going to teach them next?